Good day, everyone. I'm Cedric Steenbeke. I'm Cloud Solutions Architect with Microsoft, and I'm here today to talk to you about serverless on Azure. Now, serverless on Azure is a very broad topic, and we can talk all day easily about it and about the different services and functions below it. But today we're going to focus a little bit on the compute part of things, right? Being it is initially the evolution of the application development, or generally speaking, what is serverless, right? I think it's important to set the scene and make sure we all are on the same page when I say serverless, that we all think the same. And then we're going to dive into some of the different um, services on the Azure platform that provide serverless functionality like functions, logic apps, event grid, and last but not least, the Azure Container Instances offering serverless container environments. And then we'll wrap up with a couple of really cool learning resources that could get you started with building your own first serverless applications and get learning. Now, first things first, right? What is serverless, and why do we say it's the evolution of application platforms? Now, when you look at this slide here, you'll see that there is this distinct, or at least there is an evolution that we say, or that I see, from on-premise towards the cloud. And a lot of customers, they tend to start with a migration, just a lift and shift, right? They pick up their Apache or IIS servers, and they just drop it in the cloud. And then in later steps evolve to Paas. Now, when we are developing on-prem or before cloud, right, there were lots of questions, and there's just a handful of questions on screen now, but there's many more, right? Questions when we deploy on-prem, when we deploy on our own data centers, as how do I make sure we have power? How do we get that redundant, right? How do we do our patching? How do we install our operating systems? Who maintains our servers? Who makes sure the data center is cooled and doesn't go down because of overheating? How do I deploy my application is a question that in many steps will come back as well. So there's many questions when you do everything yourself, right? You have to think about everything. With the introduction of cloud, the IaaS became much more front and center. And with IaaS, a bunch of questions dropped away, right? We no longer have to think about how we're going to do the power, how we're going to make sure there's cooling, how we secure access to our hardware. That's all questions from the past, but we do have some significant questions still about sizing, about deployment, about patch management, about backup, right? About security. How do I secure a full virtual machine with still an operating system and all kinds of layers that require security besides your actual application security? So still lots of questions that we can improve on from a developer experience that might make your life a lot easier. And that's where Paas got introduced. And I'm thinking, or then we are thinking about things like app services, right? Azure App Services, which allow you to deploy your web application in a Paas component that handles part of scaling, but more importantly, that handles the entire abstraction of that operating system, right? You no longer have to think about how do I patch my operating system or back up my virtual machines, or how do I secure it? That's all part of the platform. That's what Azure does that for you at this point in time. What you do still have to worry about is, okay, how do I right size my my app service environment or my Paas environment, right? Do I go for a P1 or an S1 or a P3, or what kind of SKU is the right one for me? And then how do I scale, right? What is the metric? Is it memory? Is it CPU? Is it the number of requests that determine how fast or how much I need to scale to keep my application performant? So still a couple questions, a lot better than what we used to have on premise, but still quite some things we need to think about. And that's where serverless came in, right? Serverless is a full abstraction of that application platform, where the only thing you really have to think about is how do I architect my application, right? Your application, or the thing your developer needs to think about is just um, how do I develop, right? How do I make best use of this serverless platform that allows me to natively scale and get going with my application? Um, so concretely, what is serverless? Well, serverless is a full abstraction of your server infrastructure, where you no longer have to think about SKUs as much, where you no longer have to think about scalability because it's instant event-driven scalability. So the more events you send to it, the faster um, your your application will scale, and we'll have a look at that later on. And you pay for what you use when you opt for consumption-based models. There's some other things. We're not going to dive too deep into the billing plans, but there's generally speaking, if you choose the consumption-based model, which is, I would say, the most logical one, of course, you have a pay-per-use, true pay-per-use billing that is something only hyperscale cloud can provide. Now, when looking at the the different components, as I said at the start, right, we're going to look at functions, logic apps, event grid, and Azure Container Instances, but it's not just those things, right? There is a whole ecosystem of serverless components we can use, like databases, like Azure Cosmos DB, for example. That is fully serverless database service where everything is abstracted away except the database layer itself. We have the same for SQL, for example, as well. The Azure Storage Services, fully abstracted away. No longer have to care about disk management as much, about storage array configuration and the likes, networking. That's a thing from the past, and you can do that for quite a lot of services like the cognitive services platform. Now, it's all cool that there is this application platform. You also need some tools, and that's support for your IDEs, your DevOps support, monitoring, histories and debugging, and local development, of course. Right? It's really cool that all this serverless stuff is working, but I don't have an Azure on-prem to test in, right? I want to be able to still develop on-prem, make sure that those functions run, that I can emulate some of those services to make sure we we develop properly. And that's what serverless offers. So before we dive into all the specifics, let's look at a couple real world scenarios where we've seen, or where I've seen serverless being used in a real world in scenarios at some customers that I've worked with. And one is, of course, a web application backend. I think that's one of the probably most used serverless scenarios, where you essentially have an Azure function that can be an API listening for HTTP requests that come from that web application, or requests being made through a service bus that buffers all the requests, because there might be quite a lot, and then that function picking up those events that are in that queue, or those messages that are in that queue, to then process that and put that in a Cosmos DB. Another beautiful example here is real-time file processing. It's something we'll see somewhat in the next demo, or in the demo when we go into functions. And that's where, in this case, a physician uploads PDF documents to a blob storage that can then picked up by an Azure function to extract that and send that to our cognitive services for OCR detection. Get some structured text out of that, and then store that structured data into a SQL database, making sure it's queryable and accessible down the line. Another really cool example is real-time stream processing, right? Here we have an Azure Event Hub that can have massive amounts of data ingested, and then that function behind it that scales with the amount of events you get, to make sure that we have full visibility and full processing at speed of those events. Again, storing that into a Cosmos DB, which again can be super scalable, to make sure that we have everything, all data performantly processed and then visualized in a later step. And then the last one is automation of scheduled tasks. Imagine you need to do a certain task every 5, 10, 15 minutes, whatever. You could schedule a function to be time-based, and some of the other functionality as well, to be time-based and just get triggered every so much days or months or even minutes or whatever, to do a certain job, and in this case, for example, deduplicate or clean up a database. Now, the first and probably the one I've been referring to the most so far, serverless technology, is Azure Functions. And Functions is truly the center of your serverless ecosystem. Functions is a program model that is meant to have a single responsibility. It's quite important. Generally speaking, functions shouldn't be doing 100 things. They should be doing a couple of small things, but very well. They should be short-lived, generally speaking, again, right? There's always exceptions, but generally speaking, functions should be short-lived. So they're fleeting, real small interactions: create a user, get a user, update users, create to-dos, resize an image. It's fairly small actions that are gonna be triggered and run for maybe a couple seconds, but not much more, generally speaking. They're often stateless. Um, Normally speaking, functions shouldn't be holding persistent data as they're short-lived, right? You don't want to have functions that carry around a lot of historical data that should be offloaded to database systems and the likes. And they're event-driven and scaled by the amount of events they process, right? So we have events like HTTP triggers and all kinds of other triggers that can be the event triggering that function, and that also will indicate how fast or slow that function will have to scale. So functions essentially is a marriage of code that's being written and then the related events and data. Right? It's a beautiful animation there, right? That's what an Azure function is. And when we look at that code, and for the non-developers, my apologies here, but let's have a quick look at some Python code that is representing a fairly easy function. Might be a bit overwhelming, but let's get some additional information there. That REQ or rec variable is your trigger data. You have your contacts, which is the input, and your res or res, and that's your output. And we've defined that in this case in Python bindings. Now you see there three distinct parts, being the HTTP trigger on the top here, your direction, which is inbound, and the name of that variable, which is a request. So that contains all your request data. The second part is again an HTTP type. The direction is outbound, and the name there is the res or result. You could call that anything you want, of course, but I'd say keep it logical. And then the last part is about a table, an input table, which is an additional binding. We'll see in the next slide, right? So that those bindings are fairly easy in many ways to get interacted with certain functionality. And when you look at the bindings that are available, or triggers and bindings that are available, you'll see that we have, from a trigger point of view, right, from that, where does that event come from? Right, can be scheduled, as we said, can be an HTTP request. We could have a REST API. It could be a file on a blob storage being created. It could be events coming through event hubs, queues, or storage or Azure Service Bus events or messages that can trigger that function. That function then can have an additional input binding, right? You could get the input or the data of that blob storage with that trigger. You can get the same from the Cosmos DB, right? An insert in a Cosmos DB could trigger a function, and it would give then the inserted data with that function with it. And then the output binding is where can we send whatever we've done with the data we received or the input we received. Where are we sending that? And that can essentially be anything, right? The moment something has a REST API, we can, from a function, fire requests at that. Or if that's not where you want to go, we have integration, or there are integrations with Cosmos DB, with SQL, with queues and events and topics and the likes, to natively and really fast integrate with those services. So last slide before we do a real quick demo is, what is the language support? And I think that's quite important, because the misconception sometimes still lives a bit. And it's a question I occasionally get from customers like, okay, function's super cool, Cedric, but it probably only supports .NET, right? And then I'm always super happy to say, no, absolutely not. We support Python and Java and JavaScript. We even support F# and PowerShell. So it is not a .NET only solution. It is a solution that supports a fairly wide range of languages. Now let's do a real quick demo of a fairly nice function, and that is our image resize function. So it's a fairly easy demo you can set up yourself. It's one of the tutorials on the function documentation, and it will walk you through deploying each and every one of these resources. Now, when we look at these resources, right, we have our function application itself, where we have the logic and the code. We have a image resize application insights repository, which I have open in this tab as well, so we can see real time the data. Let me reset that real quick, where we can real time see the data, the amount of instances or servers we have online with usage here in the bottom of what that service is doing, and a bunch of other metrics. Really, really out of the box, right? Didn't configure anything to have this. This is just right there out of the box. With application insights. And then of course our storage account stores the code, stores the images that we will want to upload, and stores the templates that we get as a response back. And then an event grid system topic. Event grid we'll talk a bit about later, but just imagine it a little bit as the glue between me uploading a file and the function being triggered. So what this function essentially does is when I go here to my storage account, to my containers, I have images in this folder, which here I can upload an image. If you go one folder back and we go to thumbnails, this is where I would expect my thumbnails to land. Now I'm gonna open up here our Storage Explorer because it allows me to real quick drag and drop a file. So if I take here from my files here, I'm gonna upload a file. Let me real quick go to the file I want to upload. So I have my image resize here, so I can select single file, click there, upload, goes into my images. Once it's transferred, right, we'll go into that images and we'll see in a little bit, keep this open here, that our function will pick that up and generate that that thumbnail from that image. In our live metrics, we'll see it's been triggered. Happy days, right? Super cool. Our function has triggered based on that that blob there. Now, how does that work? Because I mean, very cool that it works, but how does it work? So let's look into that function itself. When we go into the function, again, you get a bunch of metrics from the get-go, but the important part here is the function itself. So we could have multiple methods. In this case, we only have one, which is event grid triggered, currently enabled, and we can look into that. Now again, when we look into that method, we can look at the integration, and then you'll see the different steps, input, the triggers, the inputs and the outputs we might have defined. In this case, I only have a trigger. If that event grid gets triggered, the function gets going and does the logic. Let's have a look. I don't think we can see the code because I deployed it from GitHub. Let's have a real quick look if it loads the code. I'm afraid not, but that's okay. The code is less interesting, right? The code is just gonna pick up that function and get going. Now in the event grid itself, we can have a look there. We also needed to do a little bit of configuration, of course, because we have our event grid system topic, and then we have a subscription within that, because we can have multiple subscriptions for the same event. And what I've done here is, of course, I created a filter, because I only want blob creation within that storage account, and I also only want blob creation within my images container. Imagine if I had it on the entire storage account, right? I would be stuck in an infinite loop because every thumbnail would also trigger that same function. So that essentially is how everything stitches together. Now, the cool thing of functions and why I have that live metrics frame open here is the scalability. So again, I just did really simple. It's a one-liner essentially to deploy that code. That code is a couple lines as well. Nothing super exciting, nothing super special, but out of the box, I get that scalability. And we can simulate that by just uploading a bunch of images. And let's see if my internet today is playing along nicely. Let's upload all my files here from that image resize repository. And I believe it's about 41 files that I still have left. So let's upload these. Let's start. And let's have a look what happens once that starts uploading to my image resizer here. So we'll see request rate goes up significantly. We'll see that the request duration went up a little bit. And I hope that I would have a couple extra servers, but I think I might have taken not enough images. Let's take a little bit bigger images and really force that function um, to process a lot more than just these few. Let me delete these real quick, and then let's upload a bigger size of the images. Let's wait a couple seconds for this to be deleted. Voila. And let's upload some other files, some larger files, because I kind of cheated and uploaded like 1-2 kilobytes files because my internet sometimes doesn't play nicely. But let's upload just the wallpapers in real size. They can be a couple megabytes, which will take the function a little bit longer to chew on them. Let's open these. Let's start uploading. It's going to take a little bit longer. We don't have to wait, of course, for everything to be uploaded. But what I want to show you here is at the moment it starts uploading, we'll see that the triggers here are going to go up. We'll see the request rate go up. We'll see the request duration go up, which is quite important. Still 0 items transferred. Let's wait a little bit for items to start being transferred if the internet today plays nice with us. Let's give it a couple more seconds. It's always the risk with live demos, right? That if there's a single thing not cooperating, it just doesn't want to go. So come on, images, let's get going. 0 items transferred. You can do it. I think I broke my demo. Let's have a look at live metrics again. Let's see what happens here. Seems my internet is not correctly working. All right, for now, let's skip this. We'll loop back if I have more luck with the demo later on. It's a bit unfortunate. The cool thing here normally is that when we upload those files, right, we see that scalability of this function because all of a sudden we upload 40 fairly large images, right? They're 2 megabytes each. We upload those and we see that the function, because it has to work fairly hard, just scales with that and starts spinning up additional instances, and sometimes goes even up to 6 instances of that function just to process that that multitude of requests to keep up and keep performant, right? So that's what we have for functions today. The next part I want to talk about is, of course, Azure Logic Apps. Logic Apps is the go-to service when you want to create integrations or when you want to do things that are workflow driven. And that's why we sometimes say Azure Logic Apps is the workflow engine born in the cloud or in Azure. So Logic Apps allows you to fastly and visually integrate components with each other, being things on-prem or in the cloud, it doesn't really matter. It's visual and it allows you in that workflow, or the Logic App Designer allows you to quickly and visually create those steps. It allows you to connect with applications, and I'll have a beautiful slide about which applications that are, and it integrates really closely with Azure Functions. Now, here is a sample of how a Logic App designer could look like, or some components at least. And you see immediately that it's quite readable, right? When a record in Dynamics is updated, we're going to do some XML transformation. We're going to register it in a data mart. We're going to do maybe some if structure where we can create a, if it's yes, we're going to create a new record. If it's no, we're going to execute a stored procedure on a SQL server. We can post message to Slack, Teams, and whatnot. And then at the end, maybe add something to a service bus topic, which in turn might be picked up by a function or a different process to continue processing that request. Now, what really is important is that, like I said, there's no code. It's fully visual, but it still allows you to work with Visual Studio to have CI/CD. So if you are working for a company or you're yourself working with Azure and you don't want to touch in a way the portal to create and configure resources, you can do that with Logic Apps, because Logic Apps is a really good plugin for both Visual Studio and Visual Studio Code that allows you to locally develop that Logic App, that integration using all the cloud um, connectors and implementations. Export that or essentially save that as a JSON, commit that in your Git, and then have a full CI/CD pipeline deploying into different environments your Logic app. Now, a Logic app, like I said earlier, has huge amounts of connectors. So we today have over 120 built-in connectors. And of course, we have lots of Azure native connectors. So you can connect almost with any Azure service that might be interesting, but it goes much further than that, right? In the sample before, we saw an integration with Slack to push messages. We have integrations with Jira. We have Google integrations, all kinds of end user applications, file system integrations and the likes. Lots of integrations there for you to choose from to build your workflows or to build your logic to integrate between applications. Now, Logic Apps do connect practically anything with anything, right? You can have cloud native things like function service bus and the likes connect or trigger your Logic app, but also databases, Dynamics, DocuSign, and the others. Now, that's cool, of course, when you're a cloud native company, but many of us are still living in a hybrid world and will be for the foreseeable future. Now, in a hybrid world, we need to still be able to get to resources that might be on premise, right? And that's something Logic Apps allows. So when you use an on-premise data gateway, you can connect to on-prem, get to that local SharePoint installation, IBM database, to SAP that might be running on-prem, or I don't know what you might still have on-premise that you need to integrate with, but you can do that through that on-premise data gateway. And from a Logic App point of view, you don't even see the difference, right? The only thing you have to indicate is when you want to trigger on a file creation, for example, an on-premise share. So say, okay, I want to use this on-premise data gateway. When a file is created in this share that is on-prem, I want to trigger this Logic app, pick up that file, do all kinds of transformations with that, and then insert it maybe in a SQL database, or trigger a REST API, or put it back on-premise in your SAP deployment. So very versatile and a really interesting service that sometimes developer look at a bit with mistrust, let's say, because how can a visual interface be powerful? But it definitely does have a place in the tool set of a developer and for sure of an integration engineer. So when we look at Logic Apps, I have a small sample here, which is a to-do Logic app. The to-do Logic app, when we go in here, you see immediately, right, we have things like versions. We have the Logic app designer itself. You can look at the code that is generated with that Logic app. But let's look at the designer. Let's edit this Logic app here. Like I said, this is a fairly simple Logic app. And once it loads, voila, here we go. We'll see that there's, when a HTTP request arrives, we have this endpoint that, of course, we can put a DNS label in front of if you wanted to make it a little bit more nicer, or an API manager or whatnot. You can abstract this. When I get in my body a user, I'm going to pick that request body up, and then I'm going to query my Cosmos DB for the to-do items for that specific user. And as a response, I'm going to just give them 200 code and the documents. If anything goes wrong, I'll get an error message or maybe permission denied if I would add some permissioning. But this allows me to real quick do a, let's say, proof of concept of an API, or maybe even just generate an API or build an API in a couple of minutes, right? If you get a little bit used to the logic app format, you can in a couple of minutes create essentially this API that gets the to-dos for a specific user. So you can use this as some sort of, let's say, scaffold to just make proof of concepts from a developer point of view, or from our citizen developers. You could use this to create your own integrations in a compliant and in a performant way. Now, I said earlier, it connects with a little bit of everything. So if I add an action in between, I can go here to all actions, and you'll see that in a couple seconds, there we go, we'll have this full list of components we can integrate with. Things like what is some interesting stuff here. I think Asana is in here. We have AS2, right? Asana is over here. We have Cosmos DB, of course. We have things like storage. We can integrate with VMs, with Basecamp, and the like. So you can just search what you need. Let's say Slack, for example. We can then do actions with Slack. I'll need to connect. I can join or post a message here, and then I could join or sign in with my account or with a service account that has access to our internal Slack or to your organization's Slack channels, and from there start posting messages to Slack when that HTTP request is received. So it's quite versatile how you can do this, and it gives you, when you of course trigger it, a nice history of runs with full visibility of what happened there. So that was a real brief overview of logic apps. I hope I explained the power, let's say, of logic apps properly. The next one we want to look at is our component within that serverless ecosystem, or Azure Event Grids. And in the first demo with the functions, I briefly already showed that we have an event grid essentially picking up on that event of a blob is being created and then giving that to a function. Now, event grids are your magic glue, so to speak, in the cloud that allow you to pick up events from publishers and then have multiple event handlers. Now imagine if we didn't use an event grid for the first example. So I just directly plug in my function on top of that blob create event. I have zero management, right, of who is subscribing and how many subscribers I have to that. With an event grid in between, I could have multiple event publishers, multiple event handlers, and I could organize which handler responds to which event and see, oh, this creation event of my images that are being uploaded, I have a thumbnail resizer program. Awesome, that creates thumbnails, but I also maybe have something to do some cognitive services, right? Some image recognition on top of those images before they're being processed. So you can clearly see what's going on there. So when we look at that event subscription, right, you have a topic, in this case, storage account. When it's created, we can trigger a webhook, do some filtering, and get quite extensive with what we want to do and how we want to handle those events. So like I said, right, event grids allow you to be reliably and performantly trigger components within your application. It's near real-time um, uh, um, latency on it. It can do tens of millions of events per region. So if you want more than that, you can use multiple regions. And it has a really high reliability with retry options and the likes to handle failures. Now, Event Grid is not the answer to all your messaging or integration questions. Event Grid is great at what it does, but there sometimes are use cases where you might want some different type of message or event or delivery system. And then we have things still like storage queues, again, a serverless component, which is Great if you want a fairly simple queue. You can still put an event grid in between that if you really wanted to, but that allows you to do some basic queuing. We have things like Service Bus, which is your go-to enterprise messaging bus with things like dead lettering and different kind of queuing mechanism. We have event hubs, which is great for streaming, like I explained in the sample application at the start. And then of course event grids, which is that reactive event managing. Like I said, there's not a silver bullet for all messaging. You will have to kind of think about, okay, which one, in my case, is the best option, right? If you have larger messages, for example, most likely you'll have to look at things like service bus storage queues, while event hubs and event grids are more for lots of triggers, lots of smaller events. So kind of find that balance between the different messaging services that to find the right one for you. Now, the last topic that I want to talk about is, of course, the Azure Container Instances um, service. Now, ACI or Azure Container Instances is true serverless container environments, right? Often when you think about containers in the cloud, we think about Kubernetes, we think about OpenStack, or we sometimes hear customers come with, oh, I deployed a couple of VMs and we're doing Docker Swarm or something similar on top of these. These are, of course, all great use cases when it's really necessary, but sometimes you just want one or two containers to run for a limited time, or you just have a small process that needs to be continuously running, which doesn't really warrant for a big AKS cluster. And that's where container instances are super relevant. Container instances are a true serverless is a true serverless container platform and allows you to run that container without managing any of that operating system in the back or any of that even container runtime. You just get access to the container and how it runs. It's super agile. You can spin up hundreds of them or just one, and it isolates the entire layer from that container orchestrator or container runtime all the way down to the hardware. All of that is abstracted away from you. So you just have to think about your container and how you'll access it. Now, when we look at the, let's say, architecture of containers or Azure container groups, container instance, sorry, it's that it works with container groups. So if you have some sort of sidecar process, you can deploy multiple containers within an ACI deployment or an Azure Container Group, as it's called. That's definitely an option. Think a little bit about the concept of pods with AKS, where in AKS you can also have a pod with multiple containers. It's the same with ACI when you deploy. Often it's a single container. Sometimes you want multiple containers, like a type of sidecar pattern to offload some certain workloads. Now, one super important thing about ACI is that it is not an orchestrator, right? ACI is great for deploying, let's say, batch workloads or things that need to be spun up, run for an hour, spun down, or maybe you need some stateful workloads that are not suitable for functions. You can use a container instance, but please do not think or use it as you would use an orchestrator like AKS. There is no such thing as like Helm templates where you can say, okay, scale my pods or scale my nodes. You spin up a container instance, you give that a certain amount of memory and CPU, and that's kind of how it's stuck. And if you want to scale, you'll have to build your own thing around it, which I wouldn't recommend personally. Now, how does it look, container instance? Well, I have a quick demo right here, which is called the SFTP deployment. So something we often get from customers is, hey, we want to run an FTP server or an SFTP server, and we don't really want to spin up a full VM for them, which I understand. You probably don't want to spin up a full VM for them. How can we fix this? How can we do this much more performant and optimized? Well, ACI might be an interesting use case where you could spin up temporarily or long-term a container for a customer to upload a file or for you to share a file with a customer or with a colleague or something. If it's too large, or you can't do it with the traditional exchange methods. So what we've done here is we've created this SFTP group which is a Azure Container Instance with, again, out of the box, all kinds of metrics towards memory, CPU, and so on that is being used, where we can look at the containers that are running within it. We have our Atmos SFTP image running here, which is public image. We can look at the properties. We see here my super secret user and password. We have some upload stuff and some properties there where we have our SFTP volume or Azure file location mounted to that volume. Um, we of course can look at the logs, right, where we can see what's happening on the container, our standard output, and we can even connect to that container. So we can go through connect here, let's say bin sh, and we can go into that container and ask, for example, for a top and see what is running inside that container. So from the start, quite impressive what kind of information we see here and how we can handle that. Now, when you look here at the IP, we have this public IP here, or this domain name, and let's have a look what happens when I go to that session, when I create a session. So you'll see here the same IP address as that container instance with my super secure password. And so I'm connected to that. I'm currently in the upload folder, and just for full transparency, let's have a look at that storage account. We have a file share in here, the SFTP file share, and there's no current files in there. So going back to our WinSCP, I have my wallpapers here, and let me upload that file into that SFTP folder here. Once that's fully uploaded, let's go. There we go. We should be able to see that in here as well, right? So this is pretty cool and very simple example of how you could use an Azure Container Instance just to do quick workloads. And we can go much more fancy or advanced and, for example, run your machine learning algorithm in here, right? When you have a machine learning algorithm that only needs to run once, twice, 3 times a week or per day, you could put it in a container, spin it up as a container instance for 1-2 hours to do that processing, because ACI does support GPU workloads. So if you need GPUs for image processing or whatever, you could include that there. Another very cool thing to do, we sadly do not have the time today to go into that kind of extensive demos, but something you could do, for example, is have a function, a PowerShell function, that when triggered over HTTP, for example, as an API, that would then in turn spin up an Azure Container Instance that does a certain job. So for example, you could automate this FTP or SFTP thing, where you might have a customer-facing portal where a customer can say, hey, I want to upload my logs or my files, or I need to exchange some data with you. You can say, okay, I want to now upload something. You trigger that ACI instance, generate username, password on the fly, spin up that instance, give back username, password, and IP address of that ACI, and then the customer can upload, and once they're finished or an hour later, you can shut down that instance and only pay for the amount of seconds you had that container instance running. So quite a cool technology. Like I said, sometimes a little bit forgotten when talked about serverless, but definitely something very cool. So let's real quick go back to the presentation and kind of wrap up, because we're nearing the end of this presentation. I think some important key takeaways, at least from my point of view, is serverless is awesome. I think serverless is probably the coolest thing you can do on, or at least the coolest service you have or on the Azure platform. And that goes for functions and logic apps, but also for all the other things like cognitive services, Cosmos DB, SQL that has that serverless tier, and so on. It is, in my opinion, where the future of cloud lays, and where I would say you probably want to invest some time in adopting and learning that environment. When talking serverless, think about event-driven and limitless scale, or at least virtually limitless scale, right? Nothing is truly limitless. Think about great for workflow orchestration. I'm mainly thinking logic apps and the likes, when you want to do EDI integration, when you need to do quick workflows, maybe send a validation email or confirmation email to people where they need to confirm certain actions. You can do that through logic apps. And they're probably one of the cheapest and more efficient ways of leveraging compute on the Azure platform. They're for sure cheaper, generally speaking, than spinning up a VM and doing the same in that. With that, let's have a look at the last part of the session today, and that's learning resources. So I can talk all day about this, but I think it's always important to part with some resources you can look into for learning. And that's, of course, Microsoft or MS Learn. Microsoft Learn, there's a full-on platform that's free to use for essentially anyone. You can register an account to track progress, of course, but even that is not really necessary. But it's a great start to start your journey on learning the different technologies of the Azure platform. And here there's three learning paths about functions, with the first one being creating serverless application, which is a full path with different modules. There's one about workflows that you could do with logic apps, and there's one about Docker containers with Azure Container Instances. So all really good resources to get learning. Do at MS Learn check, and there's some additional learning paths. Do at MS Learn check for yourself, like what other technologies there might be, right? Like logic apps, like that workflow design, deploying through Visual Studio. For containers, we have Docker containers, building web applications with Docker and doing some cool stuff with Azure Container Registry. But don't limit yourself, of course, to these services. Have a look around and maybe do some of the courses around enterprise scale or cloud adoption, or on the different programming languages that are supported on that platform. It's quite extensive. A really impressive learning platform that we have there. And with that, I want to say thank you very much for attending this session. I hope it was informative for everyone. And do feel free to hashtag or call us out on social media. And I hope you can enjoy the rest of the Cloud Lunch and Learn Marathon and learn lots of things. And with that, thank you very much for attending, and talk to you later.